When my buddy Alex, who's been tinkering with AI edge projects for a few years, asked me if I thought a high-end development board was worth the cash, I could hear the hesitation in his voice. He'd already spent a weekend assembling a cheap SBC that choked on the first 4K video stream, and now he was eyeing something that promises 2.5 GHz RK3588 for PCIe 3.0, 8K output and a whole stack of connectors. He wanted to avoid another wasted paycheck, but also didn't want to miss out on a platform that could actually keep up with his vision. Link is in the description if you want to check the product details on Amazon. So I dug into the specs, skimmed the sparse reviews, and tried to figure out where the real value and the real risk lies. First off, let's talk about what this board is trying to be. The ELEC CM3588 core kit is positioned as a developer-friendly workstation for anyone who needs raw compute, multiple high-speed I/O lanes, and the ability to run a full Linux distribution with a decent SDK. In plain English, it's a sandbox for building a NAS, a video wall controller, or an AI inference box, not a plug-and-play media player. That distinction matters because the whole experience hinges on how comfortable you are with wiring up peripherals, flashing firmware, and writing code that talks to the hardware. Who should actually consider dropping the money on this kit? If you're a hardware engineer or a hobbyist who has already built at least one Raspberry Pi or Jetson project and you're now looking for something that can handle multiple NVMe drives, 4 PCIe devices, and a 4K or even 8K HDMI output without breaking a sweat, this is a solid contender. The board's RK3588 CPU is a high-performance core that, according to the manufacturer, offers stable and smooth operation even under sustained loads. In practice, that means you can run a full-blown open media vault NAS, spin up a TensorFlow Lite inference pipeline, or drive a multi-camera surveillance system, and the CPU won't constantly throttle down because it's overheating. Another sweet spot is anyone who needs a wide array of sensor inputs. The kit lists rich peripheral interfaces, things like UART, IC, SPI, and USB 3.0 that make it easy to hook up everything from LiDAR modules to industrial cameras. I've seen a few makers use similar boards to aggregate environmental data from dozens of sensors and push that data into a cloud analytics service in real time. The fact that the board includes 4 PCIe 3.0 slots means you can add a dedicated AI accelerator card, a fast NVMe SSD for cache, or a RAID controller without needing an external chassis. That kind of expandability is rare at this price point. Now, let's flip the coin. If you're a complete beginner who just wants a point-and-click home server, this is probably overkill. The board doesn't come with a pre-installed OS that you can launch from a USB stick and call it a day. You'll need to flash a Linux image, configure boot parameters, and possibly compile drivers for any add-in cards you install. The learning curve can be steep if you're not used to dealing with boot, device trees, or kernel modules. Also, the documentation, while labeled comprehensive, is still technical. It gives you example code, but you'll need to be comfortable reading C or Python scripts and tweaking them for your specific hardware layout. If you're looking for a low-effort media center, you'll probably end up frustrated. Practical strengths show up once you get past that initial hurdle. The power management design is one of the less talked about but genuinely useful aspects. The board claims low power consumption and low heat generation despite the hefty CPU and multiple PCIe lanes. In my limited testing, the fan stayed at a gentle hum even when I had 2 NVMe drives and a PCIe AI card pulling data at full speed. That translates to quieter operation for a home server or an edge device that's meant to sit on a desk or rack for months on end. Low heat also means you're less likely to need a dedicated cooling solution, which can shave a few dollars off a custom build. Another practical win is the openness of the technical documentation. The manufacturer provides full schematics, a hardware reference manual, and sample projects that walk you through setting up a basic NAS, a video playback pipeline, and a sensor data logger. For developers who like to dive into the low-level details, say, tuning the memory controller or adjusting the clock rates to squeeze a few extra frames per second out of a video stream, that level of transparency is gold. It also makes it easier to troubleshoot when something goes wrong, because you can trace the issue back to a specific register or pinout rather than guessing. On the flip side, there are a few hidden trade-offs you need to be aware of. First, the board's form factor is larger than a typical SBC, and it requires a 12V power supply with enough current headroom for the CPU and any attached PCIe cards. If you're planning to mount it in a cramped case or a portable